Like many other air traffic service providers, ATNS has functioned on the traditional AIS system. However, the traditional product-centric aeronautical environment is not as efficient as it could be, and there are many potential errors. Currently, the challenges are mostly paper-based, AIP, SUPs, AICs. Information sharing is not seamless and standardized, including air traffic control, flight planning, billing, and other systems. These various systems are not able to speak to one another. Systems exist in isolation and were developed by different developers and on different platforms. The data is entered into these systems more than once from different machines, leading to duplication and possible errors. At the moment, the typical AIS workflow data originator gives information to the AIS or Aeronautical Information Services. This leads to the publication of charts and the production of the AIP, supplements, and AICs. From that point, the information is distributed to relevant party via the Integrated Aeronautical Package or IAIP and note. All of this information is accessed and processed by various data users. Because the information exchanges so many hands from its original point, there is the very real danger that errors and duplication of information can occur. Why is a change required? New and future technologies, computer-based navigation systems, area navigation, RNAV, required navigation performance, RNP, other ATM requirements. There is a need for current, accurate, digital, quality-assured aeronautical information sharing in a timely manner. In addition, there are many ICAO requirements that have been mandated in recent years to equip and better accommodate these new technologies. Certain ICAO requirements are specified in the following documents. The ICAO Global Air Traffic Management Operational Concept, Doc 9854. The ICAO Global Air Navigation Plan, Doc 9750. The ICAO AIS to AIM Roadmap. For ATM and AIM to prepare itself for growing needs and technological innovations in aviation, the ICAO AIS to AIM Roadmap presents some groundbreaking positioning steps. 5 of the 21 listed steps include P-06 Integrated Aeronautical Information Database, P-08 Aeronautical Information Conceptual Model, P-09 Aeronautical Data Exchange, P-11 Electronic AIP, P-20 Electronic Aeronautical Chart. ATNS is proud to present the Centralized Aeronautical Database. The CAD concept has been implemented in Europe, Canada, and Australia with great success. ATNS has acquired a solution similar to the European AIS database, EAD, to ensure that South Africa aligns itself with global initiatives and technology. The system is currently used by Eurocontrol and the European ATM community. The CAD system provides different kinds of services and functionality through various subsystems. This unique platform presents a versatile and modular solution. The main subsystems are CAD Basic, web presence for airline operators, pilots, and the general aviation public. This allows users to log into the CAD system via Internet Explorer, where they can extract the information they need directly. SDO Static Data Operation, input and output of static information. This is used by data providers to insert data into the CAD. GT, Graphic Tool, GIS visualization of static and dynamic aeronautical information and airspace design. Smart AIP, Aeronautical Information Publication, authorizing of aeronautical document. PAM, Published AIP Management System, Document Management System for Aeronautical Documents and Charts. This is a library of all the aeronautical documents, for example, AICs, supplements, AIPs, and AIP amendment. Smart Charting, Aeronautical Chart Production, System-to-System Interfaces, allows users to integrate into the CAD system with existing or new systems. This gives other users the ability to integrate into the CAD system from their own system. CAD Architecture. There are 3 databases within the CAD system: the training system, disaster recovery, and the production system. These systems are able to run interdependently from one another. If, for example, the production system was to fail, the disaster recovery could seamlessly take over. The CAA and ANSP enter data into the Centralized Aeronautical Database, which synchronizes with information contained at the European Aeronautical Database. Information that is available in the European Aeronautical Database is then synchronized back to the CAD and is made available for CAAs and ANSPs to use. In addition, it contains a web application that gives general aviation and other users the ability to log into the CAD via Internet Explorer and extract data not previously available in digital format. In support of the CAD, there is an EAD service desk which caters for operational queries and a frequentist service handling all technical queries. What CAD has to offer? CAD function. SD. The user-friendly interface allows for easy insertion of information into the database. AIP production. Aeronautical information publication is fast and simple. PAM. Published AIP management system. PAMS is a library of existing information. All the countries that are loaded into the CAD can be found and accessed with ease. Graphic validation tool. Another powerful function of the CAD is the graphic validation tool. This allows users to view the information that has been inserted into the CAD in a graphical context. Navigational aids that have been inserted can be seen. Updated airspaces are visible, and any possible errors can be corrected directly in the SDO slot management. One of the main functionalities of the CAD is to manage the information in the CAD through slots. Slots are containers for the information based on defined dates, on demand, etc., at which time it must be entered into the database. With SDO slot management, information can be moved from one slot to another with ease. All of this information goes through various checks before being entered into the regulating slot content. There are various ways of regulating the slots and the content of the information within each. The system has the ability to create reports in the SIM and presents them in PDF form. One of the key benefits of the CAD is the distinction between data providers and users. A data provider, usually data originators, air navigation service providers, or state civil aviation authorities, will insert data into the CAD via the SD, while a data or public data, usually aircraft operators, airport operators, developers, military and general aviation, will extract data out of the CAD through RAPs and access published documents via PAM. Into the future with aeronautical data not previously accessible in digital format, such as topographical and obstacle data, among others, can be entered into the CAD system and become instantly available to the entire aviation community. This can be done through a direct network connection or through an internet-based interface. Information sharing is no longer confined to specific systems, but can now be defined to other aviation subsystems using the appropriate exchange. CAD provides a database of validated statistic data, for example, aerodromes, nav aids, and it allows for worldwide data maintenance via slot management with standardized AIXM-based data exchange. It is able to apply multiple rules for data value. CAD offers reporting functionalities and upload and download management for aeronautical data. CAD. One aim worldwide. What we want to achieve with the Centralized Aeronautical Database is one AIM world. The same information available at the same time for all users. ATNS. Unlocking winning partners.